Right, welcome ladies and gentlemen. I'm going to run through your paper 3, which is the one I marked for you, and have a look at a couple of the have a look at all the questions so you can skip through to the ones that you need, but also going to run through the mark scheme and give you some exam techniques as we go through them. So most of these questions will be useful for you even if you got them right. First thing most people got wrong was that my name has an E at the end. Not important, but just for future. Alright, so nice easy couple of marks, but an opportunity for a mistake straight away. So we've got to substitute in m is equal to negative 3. So that's 4 multiplied by negative 3 squared, subtract 11 is how we're going to find t. I've used the brackets, they're important, because when we square a negative number, it becomes a positive number. So negative 3 squared becomes positive 9. So we get 4 multiplied by 9, subtract 11, and that gives us 36. 36 subtract 11 gives us 25 as our answer. First 2 marks. Making p the subject of the formula, we've got to rearrange this. The subject of the formula is a letter that's on its own on one side, so we need to get that p on its own on one side, doesn't matter which side. The easiest way to do this, to start with, I'm going to write down the question quickly, is to subtract 4 from both sides. If you subtract 4 from both sides, we get the 3p on its own, and d subtract 4 over here. Now, I've got to do the inverse of multiplying by 3, which is dividing by 3, and that gets us p is d, subtract 4 all over 3, the whole thing divided by 3. Try and write your answer in the space provided for it, but you would get marks if you left it there. Anyway, a quick note on the most common mistake that people made on this question, which was dividing by 3 first. Now you can do that, but if you divide both sides by 3 first, you get d over 3 here, which people who did this got right. That becomes a p, but I have to divide everything on this side by 3. So I then get 4/3 instead of just 4. I then subtract 4/3 from both sides, giving me p is d over 3, subtract 4 over 3. Looks different, but is also the correct answer. Just grab me a different colour pen. I'll do. Quick note on the mark scheme so you can see what they look like. So you actually got the first mark. This is a method mark, so 25 will get you the mark, and just writing 25 is enough on its own. I advise you don't just write the answer though, because if you make any sort of mistake you'll get 0 marks. But there's a method mark for just writing the negative 3 in there. Just writing out the question but with the negative 3 swapped gets you a mark. CAO stands for correct answer only. OE stands for or equivalent, so something equivalent to that, so P on the left. 1 mark for either subtracting 4 from both sides or dividing by 3, the 2 examples I gave. Right, let's speed up a bit, there's a lot of questions. So question 2, we haven't covered this yet, don't worry, I'm going to teach it to you soon. It's a transformation. When we're describing a transformation, it's worth 2 marks. One is for naming the type of transformation, and then each type of transformation has a different way of doing it. This has not rotated, enlarged, or reflected the shape, it's just moved it. It's what we call a translation. So 1 mark was for just writing the word translation. You couldn't write move, translation is what we need. You then need to work out how far it's moved. Now, lots of you figured this out, but I'm just noting 1 point, you can choose any point. Lots of you worked out how far it moves, but you also need to give the movement in the form of a vector. So in this case, it's going right 5 squares and down 1, 2, 3, 4, 5, 6 squares. And the way you write that in a vector is the x goes at the top and the y goes at the bottom. Now it's moved positive right 5, so that's x positive, it's moved 5 in the x direction and negative 6 in the y direction. You write it in a big set of brackets with no vinculum, no line like a fraction. So 2 marks, one for writing the type of transformation and the other for writing the vector. Just writing right 5 down 6 doesn't get marks. I'll show you the mark scheme in a minute. Excuse me. Length of a football pitch is 90 metres, correct to the nearest metre. Correct the error interval for this length. For those that didn't get this right, the way I suggest doing it is it's to the nearest metre. So draw yourself a little number line and do what the one above and below are. So it's to the nearest metre, which means it can't be as high as 91. That's 1 metre up, and it can't be as low as 89. So it's got to be somewhere in this range here. So that's between, sorry, I'll move my hand out of the way, 89.5 and 90.5. Now, a lot of people wrote something like 90.4 or 90.49 because they realised correctly that if it was 90.5 it would go up. It can't actually be 95, but that's what this inequality says. It's the bound. We write 90.5 even though it can't actually be 90.5, that's why it's a less than. The bounds will come up later. A quick note on the mark scheme for these two then. One for writing the word translation, one for writing that it's a vector, which cannot be given as a coordinate, and it also has to be as a vector rather than written. Second one, nice and simple, just 89.5 and 90.5. You can accept 90.49 recurring, or 90.499999. The reason for that is exactly equal to 90.5. I can prove that to you another time if you like, but that is different. That little dot means that 90.49 is not acceptable, 90.49 recurring is. Okay. Question 4. Well done on this, generally speaking. I was quite impressed. A lot of people came up with a variable straight away, which is lovely. Rick has some counters. Let's choose a letter to use that. I'm a mathematician, so I'm going to use X for that. So that's going to be Rick. Rick has X counters. And then Selma has twice as many. So Selma has twice as many, 2 X's. And Tony has 6 counters less than Selma, 6 fewer counters. So Tony has the same as Selma minus 6, so 2x subtract 6. And in total they have 54 counters. So if I add all those together, I get 54. That allows me to work out what x is, to work out how many Rick has. Some of you solve this by trial and error, and that's absolutely fine. Often this is a good way of doing it. When I add these together then, I've got 5x subtract 6 is the same as 54, and solve this equation by adding 6 to both sides and dividing by 5. So x is 12. Right, what does that tell me? That tells me what Rick has. That's useful because I need to know the number of counters Rick has to the number of counters Tony has. I need to know Rick to Tony. Rick to Tony is x to 2x minus 6. Rick had x counters, Tony had 2x minus 6 counters. Now I know what x is. I can figure how much that is. So x is 12, so Rick has 12 counters, Tony has 2 lots of 12, 24, take away 6, Tony has 18 counters. Right, great, we're nearly there. But it finally asks us to write it in the form 1 to p. So I need this left side to be a 1. So I need to divide both sides by 12. Like a fraction, you can simplify or adjust ratios like this. So 12 divided by 12 gives me 1. 18 divided by 12 is, if you've got a calculator in this paper, 1.5. You could have written 3 over 2. That's fine as well. So P is 1.5. Quick note on how you get marks for this. Well done. So lots of you managed to get the full 5 marks. The first was just writing some expressions, writing something like x, 2x, and 2x minus 6. The second was some kind of way of summing them together to show they're equal to 54. Then starting to solve it. Then finally solving it to get 12. So if you got all the way down to finding that x was 12, you've already got 4 of the 5 marks. Final mark was just for this 1 to n thing. You will notice in mark schemes like this, they allow for all sorts of different ways of doing it. So lots of you solved this by a sort of try and error method and worked out what Rick, Selma and Tony had. That's absolutely fine. Okay, ratio done. Question 5. Again, pretty well done. My speaking to you about how much I wanted you to set these out properly clearly went in. First off, make sure we read the question properly. She's buying 15 rolls of wallpaper. She can get them from Chic or Style. I very much like the people who labelled everything they're doing. It's really important for these ones where you're showing how to get your answer. You communicate what everything on your page is. So how much would it cost her from Chic? There's a few different ways of doing this. You find out how much it costs for one, or I'm going to find out the total amount she spends. So she needs to get 15 rolls. That gives you 3 rolls, so I want 5 times that. So 36 times 5. That would mean it would cost £180 total from Chic. Okay, that's Chic done, making it clear. I'm moving on to my next bit. Then she could go to Style Wallpapers, fantastically named. Now there's 2 things going on here. First off, that's what it actually costs. Then we need to reduce it. So a pack of 5 rolls is that, so she needs 3 of them, so she needs to spend £70 times 3, so that'd be £210. However, we're not done. We need to take 12% off it. We've got a calculator, so let's just do the simple way. Taking 12 off is the same as multiplying by 0.88, because 100 take away 12 is 88. We're after 88% of the price, so we can multiply by 0.88. That gets us £180. Should have got my calculator out. Sorry, £184.40. I think, just double checking. 80. £184.80. Okay, brilliant. We've got to answer the question. That's not enough. So I'm just going to put, you don't need to write a whole sentence about what's better and why it's better. You also need to do more than just saying £184 is more than £180. I'll put Joe should buy from Chic Decor. And that's enough. Now I'm going to spend a little minute on the mark scheme for this one to help show why it's important that I set these out clearly for the examiner. First off, you might make loads of mistakes. Obviously I haven't hit, well, a little bit, but if you do, we want it to be really obvious what each number is and to which thing it belongs. So 4 marks here. The final one is showing you C1. That's the I can't remember what C stands for, but it's you have to say it's Chic Decor and have the correct figures. Just writing it's Chic Decor is not enough. You need to have had, like the example I used, which is for all the rolls, £180 and £184. I think £12 was what one roll is, and a few of you did this, how much it would cost to buy 3 rolls or something like that, I can't remember. But you need the fully correct figures to get your marks. 1 mark essentially for a process of finding what it is from Chic, and then 2 marks for the Style papers. 1 for finding it would be, say, 210, and then 1 for reducing it. But yeah, don't spend too long writing loads of sentences, and also don't just, a few people wrote something along the lines of this. It's not really answering the question. You've got to say where she's buying it from. Okay, on to question 6. A lot of people couldn't quite follow this, so I'm going to start by drawing a bit of a diagram to help us out. I'm not bothered about whether it's to scale or going in the right direction, but I know L, M and N are a straight line. L, M and N. And I know the coordinates of L are -3, 1, coordinates of m are 4, 9. So I've then got to work out how to get to n. It tells me that the ratio of Lm to Mn is 2 to 3. So I can sort of divide this up. If it takes 2 steps to get there, it's going to take 3 equal steps to get up to n. Now, one way of doing this is figuring out how big that step is. So I've gone from -3, the x-coordinate is how far across it's gone. I've gone from -3 to 4, so I've gone across 7 to get to there. And I've gone up from 1 to 9, so I've gone up 8. Showing you my diagram's not to scale, but I'm not too bothered about that. So going up 8 and across 7. Now if I do that again, it'll only get me to there. I need to get all the way to n. A couple of ways of doing this. One might be to think, how far does it take? Because that's in the ratio of 2, and that's in the ratio of 3. How far do I need to go just to go one little bit? Which would be 3.5 across and 4 up. So I need to do that 3 more times. So 3 lots of 3.5 is 10.5. And 3 lots of 4 is 12. So from n I need to go across 10.5 and up 12. So my x-coordinate is going to be the 4 plus the 10.5. That gives me 14.5. And my y-coordinate is going to be that 9 plus this 12, which gives me 21. So I've gone across 14.5 and up 21. I do find diagrams for things like this can just help you get your head straight around it. You don't need to spend ages. Some people try to draw out a full diagram and plot everything in the right place, but just some kind of diagram to help show you what's going on. Lots of you manage to do it all in your head, no problem. I find these sorts of things help me process what's going on. So 4 marks there. Let's have a quick look at what they're for. For a process to work well, so 1 for essentially finding out that it went up 8 and across 7, or just one of them, just showing you've understood measuring the distance between those 2 points to some rate. Then 1 for the process of using a ratio, like halving it to find what one of them is, so halving 8 to get the 4. 1 for getting a complete process finding either the x-coordinate or the y-coordinate, and 1 for the answer. Right, that was question 6. 7. Now, I show that one. There were some people had some issues understanding the differences between sort of full equations and expressions, and demonstrating a show that question is actually quite a difficult thing. Some of you did very well, I've got to say. I'm going to... How should I do this? I'll tell you what, first off I'm going to use a proper equation for a trapezium. Now I have to show that this is 2x squared plus 20x, and there's loads of different ways of doing this, and however you did it, as long as you get your algebra right, you're fine. I could do with finding out that length and that length to start with, because the area of a trapezium is equal to half a plus b times by the height. Now in this case a half, that's easy. The a plus the b, that's the 2 parallel sides. That one's 5. This one, well, I can work it out because I know all the way across there is 3x plus 5. And I'm 2x across there, so I've got to go another x and then my 5. So that must be x plus 5. So my 2 parallel lengths, when I add them together, a plus b, are going to be x plus 5 plus 5. Then I need to times by the height. Well, this whole thing's a rectangle, so that's going to have to be 4x. So I'm going to times the whole thing by 4x. Now, because this is just things multiplied together, I'm going to make my life easy by doing this half times the 4x first. That gives me 2x. I'm going to simplify what's in this bracket here. X plus 5 is x plus 10. Now, when I multiply these out, so I should have put this is all equal to the area A, QUVR. Hopefully you read the question before you watch this anyway. I've got to multiply these together now. 2x times x is 2x squared. 2x times 10 is 20x. There's lots of other ways people did this, and it's fine however you managed it. Some people work this out as this is a rectangle and it's 5 times 4x, so that bit's got to be 20x, and then figured out this triangle here being 4x across and worked out that that needs to be an x over there. Apologies if you can hear my cat, she might come and jump up in front of us in a minute as well. So 4x by x, and use the equation of a triangle to find that one. However you did it, it's fine. I won't spend long on this mark scheme because it's so hard to discover what's on there, but essentially whatever method you use, there's some marks at different parts of it. But even just labelling these sides, as soon as you see a diagram, if you're stuck, if you don't understand how to start it, start off by labelling some sides and finding any areas you can. You might squeeze a mark or two. Don't waste too much time on it, but even if you can't follow what's going on, if you've got a diagram with showing something, then just find some lengths and some areas. That is fine. Very little working, but it works fine. It's only 3 marks. Excuse me. Right, so this is a cuboid placed on the floor. It's a compound measures question. Now, it tells us that the face is in contact with the floor has a rectangle of length 1.2 and width 8. So I know that this is the bottom of the cuboid and it's got a length of 1.2 and a width of x. So that must have an area of 1.2x. Before I go any further, I'm just going to write that down. So I know the area of that is 1.2x. That's one of my things already. We've got to figure out what that x is. We can make another equation now. It tells me what the pressure is, 187.5, and it tells me what the force is, 180. So pressure equals force times area. So pressure equals force, I meant to say divided by area. We could swap this around now to make A the subject to the formula if we wanted, or just substitute it in as it is. Well done to those of you who did straight away realise that what we're going to have to work out is the area, so we can rearrange that to get F over P. A lot of people got these the wrong way round though. I tend to like just sticking to what I've got here, and then once I've got all the algebra in, solving it afterwards, I find I make fewer mistakes. So pressure is 187.5 newtons per metre squared. Just checking, is this area? Yeah, the area is in metres as well, so that is in metres squared. If that were in centimetres or something like that, it would be a much harder question. So pressure is 187.5. Force is the numerator, that's 180, and the denominator is 1.2x. I can multiply everything by 1.2x and divide everything by 187.5 if I wanted. And that gives me, I'll find some answers. I wish I had my calculator with me, I will go grab it in a minute. My 1.2, actually I'm going to pause and get my calculator. And just like that, oh, it doesn't show up very well. Got my calculator. So 180 divided by 187.5. So it gives me it as a fraction. I'm always going to write down a fraction as I go along, unless it's my very final answer and it's told me to round it. Always write down any exact numbers you have. So 24 over 25. Finally, I need to divide everything by 1.2, so I need to divide that answer by 1.2, getting me 4/5. You can leave it as 4/5, or you can write it as 0.8. I like fractions. Just double check, it doesn't ask me to write it in any particular way. Nope, 4/5 will do fine. But 0.8, also great for your mark. Okay. Generally speaking, not too bad. You can't see very well in this video. But a power of 10. The few people who didn't get this right, there were two main issues. One was not remembering what a power of 10 meant, and one was not remembering the indices rules. So a power of 10 means 10 to the power of something, just on its own, not 1 times 10 to the power of x, not 10 times, it's not standard form, it's just 10 to the power of x. So I'm going to simplify this so that all I've got is 1 power. Now I'm going to use sort of BibMass rules, so the last thing I'm going to do is that square root, because that counts as the indices in BibMass. I'm going to do this multiplication first. So 10 to the power of 50 times 10 to the power of 90. Rules of indices, when we multiply these together we add them, so that gets me 10 to the power of 240. The denominator, and 10 to the power of 360 hasn't changed. Sorry, it's difficult to read, but I can live with it. Next I'm going to do this division. When we divide, rules of indices, we subtract, so that gives me 360 take 240, gives me 10 to the power of 120. This final bit is a bit sneaky. Hopefully you remember that square root is the same as to the power of a half. So essentially I've got that whole 10 to the power of 120 all to the power of a half. So the final rule of indices, we use most of them in this question, is that when you've got powers like that, we multiply them. It's not the same as up here. When we multiply, we add the powers. When we powered the powers, we do a multiplication. So that gives me 10 to the power of 60, and that is your correct answer. Your answer has to be in the form 10 to the power of something. Just check if there's anything worth mentioning on the mark scheme there. Don't think so. But I do want to talk about this final question. Some of you wrote me a little essay. It's 1 mark. No, it's 1 mark. So Liam's made a mistake. And it tells us that as well. Liam's method is wrong. Explain why. If something's wrong and you've got to explain why, just a correct counterexample would be good enough. I'd do something simple like it should be. I don't even need to write those 3 words, I don't think. We've just done this power here. We multiply them together, we don't square them. So 50 times 2 should be 12 to the power of 100. Just to prove to you that I'm not talking rubbish, that's all we need. You don't need to write an essay about what Liam's life choices are. So mark for correct reasoning. So he should do 50 times 2. That's good enough. Or just because 12 to the power of 50, that's pretty much what I wrote. Or you could have even written, when you have a power inside and outside a bracket, you times them. So just timesing, not multiplying, is good enough. Or just give the general index rule, which is a lovely way of putting it. I wish I'd done that just now, actually. Too late. But do look at the marks and don't spend forever writing things down if it's only worth a mark. Counter examples, if something's wrong, just give a counter example. That's always enough. Right, Jane's been buying a car. The biggest problem people had here was there were a couple of issues actually. Just going to talk about a general thing actually. So this is an opposite of a reduction. Let's say something cost £1,000 and I reduced it by 25%. Hopefully you can work out in your head, it would be £750. And reducing it by 25% means I've multiplied by 0.75. Now, the biggest mistake that people make is that to get back, if you say, well, what was the original price? If they'd told us it's £750 and it was 25% off in a sale, a lot of people go, oh, well, I'll take that and increase it by 25%, which would be the same as, let's clear that, oops, okay, sorry about that, 750 multiplied by 1.25, so lots of people try and increase that by 1.25, which gets us not enough. It doesn't get us back to 1,000. That's because 25% of 750 is less than 25% of this. When you are undoing a percentage reduction, think about this diagram. The opposite of multiplying by 0.75 is dividing by 0.75. I would get my calculator back to prove it to you, but I don't want to blind anyone. So think about this diagram. When you are undoing a percentage reduction, you're going to divide by the original amount. That's a general thing to help us with this question. So Jane's new car 3 years ago. So he's got her original price. I'll call that X because I'm a mathematician. And it's gone down by 12.5%. So 100 take 12.5, that's 87.5%. Yes, so it's been multiplied by 0.875 to get the amount after year 1. So that's 1 year. Then it's been decreased again. So that's year 1. It's been decreased again, but this time 10% each year for the next 2 years. So it's gone down by 10%. So it's multiplied by 0.9 to get year 2. And then one more time multiplied by 0.9 again to get year 3. Now we know year 3, it actually tells us year 3 is £17,010 more expensive than any car I've ever owned in my life. Don't be a teacher if you want to be rich. I need to get back to the original quantity. So I need to undo this each time. Divide by 0.9, divide by 0.9, divide by 0.875. Rather than plugging it into my calculator, I'm just going to get the answer off here, which is £24,000. When you get a nice round number like this, you can be fairly confident. Isn't always the case, as we'll see later on with some percentage questions. But if you'd increased this by 10%, increased it by 10%, and then increased it by 12.5%, you'd have got less than this. And sadly, lots of people missed out on lots of marks because using 1.1 and 1.125 doesn't get you any marks. You've got to get the correct step for each one. So sadly, lots of people did lots of work, wrote it down on the calculator, but couldn't get any marks for this. Reversing percentage decreases and increases will come up, and hopefully fewer of you will make this mistake next time now that you've made it once. Okay. Listing outcomes. Raheem has a lot of shirts. He loves his jeans as well, apparently. He's going to make some outfits. So you could start writing these down. There's 16 shirts, so you could wear shirt 1, jeans 1, and oh no, that doesn't work. I'm going to put P for pair of jeans 1, and then jackets 1. Then he could wear shirt 1, pair of jeans 1, jacket 2, shirt 1, pair of jeans 1, jacket 3. You might realise this is going to take forever. There are 16 shirts. There's a lot of these. All we have to do for this is multiply them together. 16 shirts, and for every shirt he could wear a different pair of jeans. So just his shirts and jeans, without even thinking about the jackets, I mean, he's got 90 different combinations he could use. No, 80. 5 times 16 is 80. 80 different combinations he could use. But then with each of those 80 different combinations of outfits he could wear, he can wear a different jacket 3 times. So 3 times 5 times 16, which gets us 240. Nothing fancy in the mark scheme for that. 1 mark for writing multiply them, 1 mark for multiplying them correctly. Right, so lots of people tried to do things a lot more complicated than they needed to here, but thankfully lots of you remembered it was trigonometry. The first thing I do when I can see I've got right angled triangles, angles, and I need to find lengths is write down my trig ratios quickly. So Katoa helps me keep my mind focused as I go along. Next, this is if that's 45 degrees there and that's 90 degrees there. Oh, also, I'm trying to work out AB. I'm trying to work out this side. So I need to, if I was using Pythagoras, I'd need to know 2 different lengths. But I've already got 1 angle, so I just need either of those lengths. So this one, I can do some fancy stuff to work it out. Or you can just realise that if that's 45 degrees, this is 45 degrees, which means if 2 angles are the same, it's an isosceles triangle. So that has to be 8. As a quick note for those of you who tried to use trigonometry to do it though. If you did, what we've got is 45 and 8. And for those of you who tried to use trigonometry for it, I'm trying to work out this side here. I'm going to label that. That's the opposite side. That's the adjacent side, so I'm using the opposite and the adjacent. That means I've got to use this tan. So tan, and I'm trying to find the opposite, so I'm going to use the formula opposite equals tan times adjacent, or opposite is tan 45 times 8. You'll notice in your calculator, and hopefully you'll remember, if you don't do yet, you'll remember by the exam that tan 45 is 1. So that means that length's just 8. So if you tried to use trigonometry to figure this out and something went wrong, that's for you. Hopefully lots of you, well, I know lots of you just spotted this is an isosceles triangle straight away, so that's an 8. Right, so now I've got this triangle. I'm just going to draw it again so I don't get confused. Good hint for the exam, especially when you've been drawing lots of things. So I've got this triangle here. I'm trying to find out AB, so I'm going to call that X. That angle's 20. That length is 8. Alright, trigonometry. I'm trying to find out the hypotenuse, and I have information about the opposite. Opposite and hypotenuse means I'm using sine. I'm trying to find the hypotenuse, so hypotenuse is opposite divided by sine. Hyp is op divided by sine. So that's X is 8 divided by sine 20. 8 divided by sine 20. I'm going to type this in actually because of the significant figures bit. 8 divided by sine 20. Yeah, I'm in degrees. Gives me 23.3904. Blah, 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 blah. I need it to 3 significant figures. For 3 significant figures, I always think draw a line after the third significant figure, and then decide, is that going to stay as 23.3 or does it go up? They're the only options. Is it going to stay as 23.3 or is it going to go up? It's going to have to go up, and go up to 23.4. Okay. Quick note on these. One for finding there is 8. No, nothing particularly fancy in here. Oh, interestingly, you would have got away with 23.3. Yeah. It's easy these days for you guys, eh? Okay. Right, an inverse proportion 1. Now, questions that have things with people doing jobs are a little counterintuitive in some ways. I always like to think of it as how many working days is it going to take. So, if it takes 6 workers 14.5 days, how long would it take one person to do it on their own? It's going to take longer than that. We're not going to start by doing 14.5 days divided by 6. We're going to start by working out how much it takes one worker. That's the key bit to these questions in my mind. There is an inverse proportion method, but for written ones like this, I think it's more important to understand this sort of idea. It's also a more useful thing in skills. So one worker would take, how long? 6 times as long as it would take 6 workers. So 6 lots of 14.5. Can't be bothered to do it in my head right now. 87. So it would take one worker 87 days. Now I've got that. There's loads of different ways I can go finishing that. So for example, I can find out Kieran's got 13 workers. So if I divide that by 13, that'll tell me how many days it takes them to finish it. Or if I divide it by 7, it would tell me how many workers it would take to finish it in 7 days. I'm going to go with, I like that idea, how fast is Kieran going to finish it? 87 divided by 13. So 13 workers will take 6, roughly 6.69. Just going to put 3 significant figures, not important. 6.69 days. All right. Well, 6 points. So final concluding point. That's not enough. It's show that Kieran has enough workers. I'm just going to make absolutely certain for the examiner 6.69 is less than 7. So Kieran has enough. Let's look at the marks scheme for that. Only 3 marks. I don't want to spend any longer than that on it. Marks scheme coefficient 13. Kieran, here we go. Right. So lots of different ways of doing it. You might have done it a different way as well, by the way. But one for working out how many days it's going to take. The main thing I wanted to work on was this. Oh, actually, no, we don't need to write something out. Just writing 6.69, as long as it's clear what it is. So I wrote 13 workers will take that many days. Anything that show, I want to be clear to the examiner. I'm not writing whole massive sentences, but I'm being clear to the examiner what each step, what each number means. If you just have 6.69s and 7s and 13s and 87 spread around your page, it doesn't make any sense. It doesn't need to be much. You don't need, but I think that's a pretty concise way of putting it. Do make sure that it's obvious what goes where, what each number means. Sorry. Okay. Enough of that. Factorising fully. Oh, this went terribly. But first off, let's have a look. Is there anything in common between those two? And I'd say yes, there is. So I'm just going to adjust my focus, see if I can. That's a bit better. Yeah, that's a bit better. There's a number in common between these two terms. I could start off straight away by writing p squared minus 9. That fits in there, and that would have been worth a mark. However, it is not fully factorised. Lots of you saw me underline the word fully on yours. Very few people remembered this difference of two squared things, and it has been over a year since you studied it, but the difference of two squares, that's a square, subtract a square. That's the same as p plus 3, p minus 3. That is your answer. And just explaining why that is, when you have a plus 3 and a minus 3 like this, when we expand this, the number of p's is going to be 0, because p times p is p squared, p times negative 3 is minus 3, 3 times p is 3p, 3 times negative 3 is minus 9. That minus 3p and the plus 3 disappear, and I just get p squared minus 9. If you end up with a square, subtract a square, difference of two squares, you've got to look out for this. They'll throw one in there somewhere, and hopefully it'll just be a little one like this where you'll only lose 1 mark if you don't spot it. Now, I mentioned earlier about people getting confused between equations and when you're just doing some algebraic manipulation. There is no equals in here. And also the fact it's got all these A, B, C's and D's looks complicated. It's just saying it can be written in this form. Now there's no brackets in there, but there are brackets here. Most of you worked out I need to expand these brackets, which is great. Some of you decide to set it equal to something else and then start trying to solve it or anything like that. We don't need to. I'm just going to go down, gradually taking this at the start and turning it hopefully into something that resembles what's at the bottom. So, grab a different colour pen. We'll start by multiplying out that bracket. M times n, 2m squared, m times minus 5, 4 times 2m, 4 times negative 5. Right, all of that stays in one bracket. I'm going to multiply all of that now in a minute by 3m plus 1. Make my life easier, I'm just going to simplify this a bit first. So that's minus 5m plus 8m, so that would be plus 3m minus 20. 3m plus 1, right. So all I've done so far is expand that bracket. You could have done the other one first as well. It doesn't matter what order you do it in, you'll always end up with the same answer at the end, and the mark scheme allowed for you doing things in different orders. Now this was 3 marks. The first was for correctly expanding one of the brackets. Now I'm going to multiply all these together. Now not everyone was happy with this concept, but I've got to do 3m times all of them and 1 times all of them. I tend to work left to right, so I'm going to do 2m times 2m squared times 3m. So that's a 6m cubed. Lots of people lost powers as we were going along here as well. You've got to be really careful to remember what you're multiplying by what. So that's 2m. I've got to do 2m squared twice. Once times that, and then once times the 1. Great, so that's that one done. Next, 3m. 3m times 3m is 9m squared. 3m times 1. Minus 20 times 3m is minus 60m, and minus 20 times 1 gives me minus 20. I'm almost there. I've got some cubes, I've got some squares. I feel like something's gone wrong all of a sudden looking at this though. Yeah, that should be a squared. Whoops. 6m cubed. Yeah. I've got a cubed, I've got some squareds, and I've got some m's, just linear terms, and a constant. So all of this now though, I need to show it can be written in that form, so I need to simplify it down. That's not in this form. I just need 1m cubed, or 1 cubic term, 1 quadratic term, 1 linear term, and 1 constant. So that's the only 6m cubed. If I gather together my m squareds, I get 11m squared. Gather together my m's, that's minus 57m, and a negative 20 at the end. Double check I've got this one right. It'd be a pain to finish this video and go back and try and edit it. Yep. Great. It's question 14, 3 marks. 1 for expanding a pair of brackets correctly. And then the second mark was for getting, I think, something like 4 of these or 3 of these terms correct. Final mark for getting everything perfect. I don't need to state what A, B, C and D are. You can do if you want, but it's implicit from the way I've written it here. This is just saying that should be a whole number, constant, a number times m cubed, a number times m. It's implicit that in your answer that you figured out what A, B, C and D are. Right, circle theorems 1. We're going to talk more about the how to form your explaining answers or proving questions. Anything that is prove or give reasons to your answers it involves a few steps. So first off, I've got to prove these 2 triangles are similar. 3 marks. Don't spend forever on it. It's 3 marks. I've got to prove they're similar. Now there's a few different ways you can prove triangles are similar. Probably the easiest way is to spot that all the angles are the same. Like if you know all the angles are the same in 2 triangles, then they're similar. So first off, I can do that. I know that this angle here and this angle here are going to be the same as each other. I'm going to call that A and that A. It's going to make my life a bit easier as I go through. I could write PXQ and SXR. I'm just going to label them. I know those 2 are going to be the same. Then, because of a circle theorem that we did recently, I know those 2 are going to be the same as each other, and those 2 are going to be the same as each other. I've essentially kind of snuck a mark already. It's 3 marks. 1's for getting that all 3 of the angles are the same. Well, depends how you mark it. 1's for explaining your reason why. It's not just enough to say they're true. You've got to prove they're true. You've got to name the correct theorems. And the final one is to say if all 3 angles in 2 triangles are the same, then they are similar. So I'm going to explain them why. So angle A and A are the same. So I'm going to put A equals A because I'm just being lazy here, to be honest. Probably not the best way of doing it. You should maybe be writing SXR equals PXQ, but I've just written A equals A. Because, and the actual proper term for that is vertically opposite angles are equal. Vertically opposite. I think it's just enough to write opposite and just to check. Right, if I look at the mark scheme, it says, right, anything that's underlined has to be shown. So opposite angles or vertically opposite, but just opposite angles. You have to have the word opposite or vertically opposite to get the mark. Okay, it has to have the word opposite. So that's the really important part of that. Vertically opposite angles are equal. Now B and B are the same because I'm going to write a shortcut. Angles in the same segment are equal. Now that's a bit of a shortcut, but that's because I know that's just enough. angles in the same segment are equal. If you want to write it properly, angles at the circumference subtended from the same arc or chord of a circle are equal. Now, because I know it's just enough to write angles and same segment, the underlined words have to be shown. So I'm going to go with that. I will be teaching you exactly what to write. The shortcuts, we'll get some notes on it, okay? But angles in the same segment. As long as I've got those words, angles and same segment, I'm getting my mark. So I know they're the same. I know they're the same. Finally, these are the same, exactly the same reason. I'm just going to write it all again, but you could come up with some kind of shortcut. I think it might be more confusing though. Angles in the same segment are equal. Now, I've not spent a while identifying this circle theorem. I know lots of you did, and you just wrote things to me saying something like, because of a circle theorem, or because of that circle theorem that you taught us, I know they're equal. But now you know you have to write angles and same segment to get that mark. Right, so I have proved that A and A are the same, B and B are the same, and C and C are the same because of those rules. I'm not finished yet though. I've got 1 mark for identifying that they're all the same, 1 mark for correct reasons. Final mark is therefore triangle PQX and SRX are similar because they have 3 equal angles. You may remember from your proof about there's different ways of doing it. You can have side, 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 angle, side, angle, 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 whichever ones they are. I won't go into that now, but I need to give the reason they are similar, and 3 equal angles is enough of a proof to say they're similar. Let's just have a look what it says in here about that. Stating that triangles are similar because all 3 pairs of corresponding angles are equal with complete reasons given. Oh, brilliant, yeah, got my mark. Okay, right, enough on that. I'm going to take a quick break. Okay, I'm back. 7 questions to go, the 7 hardest. And this is one in which I'm certain we can all start picking up some marks for the next mock and the actual GCSE. There are a lot of mistakes. We need to work out the upper bound for P. So that an upper bound means the highest it can be. It doesn't actually have to equal that one. So I was talking earlier about bounds. I'll mention it again in a second. But the first thing I'm going to do, there's a couple of steps that go in. So I don't know what 6.8 is. It could be higher than that, and it could be lower than that, and it could be F could be higher or lower than that. The first thing I'm going to do in any question like this is work out what the actual bounds are of E and F. So E is 6.8 correct to 1 decimal place. So it could, the next one up from that is 6.9, and the one down from that is 6.7. It's got to be in this range here, somewhere between 6.75 and 6.85. So E is somewhere between those values. I'm going to worry about which one I need later, but that's the first thing, is finding what the bounds are for E. I'm going to do the same for F. F is 0.05 correct to 1 significant figure, so 1 significant figure, where the next highest up from that is 0.06, the next down is 0.04, so it's got to be somewhere in this range between 0.045 and 0.055. So F is somewhere between those two. Now, working out those ranges is the most important thing to do to start. Now, I'm just going to take a moment here to talk about which of these I have to choose, because in a minute I'm going to substitute them in to this formula, 2E over F, and I need to choose the E and the F, which is going to make the highest value of P. So a quick note about dividing. If I can choose, say, 7 or 8 to be my numerator and 3 or 4 to be my denominator, okay, and I'm going to do A divided by B, what's going to give me the biggest answer. Well, I could do 7 divided by 3, 7 divided by 4, 8 divided by 3, or 8 divided by 4. Now, everybody correctly chose that we want a big number. We want the numerator to be the highest it can possibly be. So I'm going to choose 8 for my numerator. If I choose 7, it'll just be smaller no matter what. So I want this to be the maximise this. So I'm going to choose 8 as my numerator. So I can either do 8 divided by 3 or 8 divided by 4, which is going to be bigger. Naturally in your head you kind of think, oh, I want the biggest thing, so I'm going to choose the biggest number. But 8 divided by 4 is just 2. 8 divided by 3, to be precise, is going to be specific, 2.6 recurring. That's bigger. You get a bigger answer with a smaller denominator. Sort of makes sense when you think about it. If you're dividing things up into as many piles as possible, you divide it into small piles. But at the risk of confusing you, the important thing is, if you want to maximise a fraction, you want the highest numerator possible and the smallest, the lowest denominator possible. So, what does that mean for my question? It means I need to choose the highest value of e I possibly can, but the lowest value of f I possibly can. So my key numbers are 6.85 and 0.045. I'm going to substitute them into this equation. So on the numerator I've got 6.85 and on the denominator I've got 0.045. That's my key bit. It's so few people remembered or worked out to divide by the lowest number. We then plug that all into our calculator. I'm just going to look up what the answer is because I know my working's correct. It gets, actually, no, I need to put it into a calculator, don't I? Because I'm going to have to round it. So, 1 second. The square root of fraction 2 times 6.85 divided by 0.045 gives me a complicated, messy thing, or 17.4483 because I'm being asked to show it correct to 3 significant figures. 3 significant figures. 1, 2, 3. Is it going to stay as 17.4 or go up to 17.5? Well, because of that 4, it stays as a 17.4. And I'm working out the upper bound for p. Now, some people didn't like the fact that it says upper bound. It can't equal that because e can't equal 6.85. F can equal that, but because it can't actually equal the highest amount, they were unhappy about that. But an upper bound doesn't mean it can actually be that value. It's the bound. It's a mathematical term for it cannot be higher than this. Okay? So that's the upper bound. Few things to remember there, but the main thing I want you to take from this, we can definitely all pick marks up on this in the future, is that if you're maximising a fraction, choose the smaller denominator. It may come up the other way around and you're having to minimise it, in which case we'll be choosing a big denominator and a small numerator. Okay, question 16. Question 17, lots of opportunities for mistakes and also a very small space in which to write your working. Now, a couple of things I want to point out to start with, 2 major mistakes. First off, this says 120 pi centimetres cubed. Lots of people just read 120. Take your time. 120 pi is bigger than that. Pi is just a number. It's like 3-ish. And we all know that people can list it to huge digits and things like that, but it's roughly 3-ish. The total volume is about 360, not 120. So that's the first thing I want to point out. Take your time when reading these questions. Now, we need to work out why. And 2 things I need to know for this. The first is, how long's that bottom part there, the hemisphere, and how long's that top part? Well, that top part is just h. We'll work out what h is in a minute. And this bottom bit, well, that's from the centre of the hemisphere down to the very bottom. The idea of a sphere is that the whole thing, the radius all the way around is the same. So that is 3.5 or 7/2. I like to keep fractions and avoid decimals, but if you wrote 3.5 all the way through, this is absolutely fine. So if I can find out what h is, I add 7/2 to it and I've got my answer. They're the two main mistakes people made to start with, those that had a good effort at it. First was forgetting that, or missing that had a pi, and the second was going through all the complicated stuff to work out how high that cone is and then forgetting that you had to add 3.5 to it. So how do I work out that h? Well, it tells me the whole volume of this whole weird shape. So if I can work out the volume of this hemisphere, I can subtract it from that whole thing to give me the volume of the cone. Then I can use this formula to work out what h is, because I know what r is. R's 3.5. So let's start by finding the volume of the hemisphere, and all the way through I'm going to make it clear to the examiner what each bit is. So volume of the hemisphere, well, first thing I'm going to do before I forget is it's going to be a half of this. Another common mistake. Volume of the hemisphere is half of that. A half, 4/3 pi 7/2 cubed. Oh my goodness, the amount of people who read that as a squared is frustrating. If you've made that mistake now though, that's a good thing. Hopefully you won't make it again in the actual exam. So I'm going to do a couple of things on my calculator. I'm going to work out what 7/2 cubed is. Actually, I'm just going to type this whole thing in one go. Times by 4/3 times by pi. Right, oops, damn, gave me the wrong answer. I'm going to try and keep things as exact as I can. Right, start that again. So a half times 4/3. That's 4/6 or 2/3 to make things simpler, or 2 pi over 3. So all that simplifies to 2 pi over 3. 7/2 cubed is 343/8. Now to help keep things simple, and you don't have to do this, I'm going to keep things in terms of pi. So that multiplied by 2/3 multiplied by 2/3 gives me 343/12, and that's 343 at pi by 12. It's an ugly number, but you could have just got that as 28.5 being the roughly 30 is the volume of the sphere. Sorry, just took a moment because I realised that was wrong. It's this times pi, so it's roughly 90 is the volume of the sphere. Right, so volume of the hemisphere, great. Now the volume of the cone. Volume of the cone is going to be 120 pi subtract all this nonsense. So subtract answer, that's 1097 pi by 12. If you were working that out, in decimal form, we're roughly 270-ish is our volume of the cone. Right, now how does that help me work out h? Well, I know that is equal to the volume of a cone is 1/3 pi r squared h. So I know that is the same as the volume of the cone is 1/3 pi r squared h. Well, my r is 7/2 times by h. That's the same as this. Now I've got something I can simplify to just find what h is on its own. And a couple of things to start with. I'm going to divide both sides of this equation by pi, and I'm going to multiply both sides by 3, so that 1/3 disappears, and that becomes out 4. Sorry if you're not following this step, but the most important thing is figuring out how to get this equation, not necessarily solving it. Right, so then so that's 49 over 4, or 49h over 4 is equal to 1097 over 4. So 49h is the same as 1097, multiplying both sides by 4, and then dividing both, so that tells me h has to be 1097 over 49. Does that give me a nice answer? 1097 divided by 49. No, it doesn't. Just checking I've got that right according to Mark's scheme. Okay, great. So that's h, and that's correct, which is roughly 22. However, I'm having to find out y. Now I worked out up here, y is h plus 7 over 2. So I've got to do 1097 over 49 plus 7 over 2. So that plus 3.5, which gives me that 2537 over 98, or 25.8877 more. So rounding that, then I've got to give it to 3 significant figures. My third significant figure is there, so it's 25.8. No, I'm going to round up to 25.9. Okay. Couple of notes on this one. First, notice how I kept, and sorry if it got more confusing for you this way, I kept everything as exact answers the whole way through, and that allowed me to not have any rounding errors, not end up writing loads of decimal places all over the place. I just kept things as fractions and kept it exact. That is an exact number. I haven't had to round it at all, and that gave me an exact volume of the cone. Then allowed me to cancel out some pi's and things, getting me a nicer answer. But if you write it in decimals all the way through, that's fine. Just be careful that you don't lose accuracy when you go through, because every time you round something it becomes less accurate. So for example, 343 pi divided by 12 is, and I see it gives it like to me like that on my calculator, but it's 89.797, and if I'd written 89.8 say, then I'm not using an exact answer to get into this. I then round that and not use an example all the way through, and you end up being slightly off. They do make account of that in the mark scheme, because they know people will round at different points. Even though the exact answer is 25.9, anything between 25.8 and 26.3 was worth the correct answer mark. Okay, but it's just showing you, because I'm making this video, the best way to answer questions like this are to keep things as exact as you can all the way through. Right, finally, just one mark, this one. The diameter of the base of the cone and the diameter of the base of the hemisphere are both increased, so it's getting fatter, essentially, this this shape, whatever they're calling it. And assuming the total volume of T does not change, so the base is getting wider, that hemisphere is getting bigger, but the total volume of the whole thing is not changing. Well, if the hemisphere is getting bigger, what's that going to do to my answer part A? In order for the volume to stay the same, this cone's going to have to start getting smaller and smaller and smaller. So the height, or y, is going to decrease. So y would decrease. One mark, that's all I need. Just write that it's going to decrease somehow. It's going to get smaller. It gives you 3 lines. It's 1 mark. It's just asking, and generally speaking as well, worth having a guess on some of these, even if you're not understanding what's going on. If it's talking about an effect, there's 3 things it could be. It could stay the same, it could get larger, increase, or decrease. Stay the same, increase, decrease. Worth a guess. just put one of those three and you've got a 1 in 3 chance of getting a mark. Right, getting on to the really tough stuff. Lots of opportunities for mistakes in this one, but this 3D trigonometry, I know you're just doing it with MIS and we're not there yet, but the main point I want to make is that lots of people didn't understand what angle it was asking us for. The angle between a line and a plane is going to be this angle here. I'm going to call that theta. That's the angle. That's what I'm looking for this whole time, is to work out how big that angle there is. This line underneath needs to be, this whole triangle needs to approach it the same way. I find it very difficult to describe, being a maths teacher, that's not a good thing. But this line has to go exactly underneath the line above. So that's the angle I'm looking for. So it's going to be a trigonometry question. To work that angle out, I need two of these lengths here. Either that length dt, SD, or ST. Well, ST is going to be really difficult to work out because I don't know any of the other things around it. So I probably want to work out SD and DT. Let's start by figuring out this SD. And it gives us a hint to help this by telling us that the cross-section of the prism is in the shape of a trapezium of area 147. It's telling us that the end of that shape, terrible diagram, SDCR, that's trapezium. It tells us the area is 147. Now what else do I know about this? Well, it tells me RC is 12, and it tells me the base is a square, so this DC must be a 14. So I can use the formula for the area of a trapezium. Area is equal to half A plus B times by H. A plus B are the two parallel sides. So what area is 147? And that's going to be half times A plus B, so that's 12 plus SD, multiplied by the height. The height is 14. Lots of people got confused about what the base and what the height is. The A plus B are always the two parallel sides. The height, in this case, you might think of it as a width, is the other length, not the parallel sides. So 12 times 14 is 7. So 7 SD plus 12. So then I need to divide both sides by 7. 140, so that's 21. That's nice and easy. SD plus 12. So SD is going to be equal to that. Take away 12. So SD is going to be equal to 9. Right, brilliant. I've got one of my two lengths already. Now, as soon as I can find that other length there, I can do some trigonometry. So I need to work out DT. The way to work out DT is to realise that we know that length there, and it gives us some information about TC. So I can kind of start working backwards. I'm going to look at this triangle here. The one that goes from D to C to T. That's a right angled triangle, and I know that length is 14 because it's a square at the bottom. And I'm trying to work out DT. Once I've worked out DT, I'm there. Well, I've got to do one little bit of trick. So CT, what does it tell us about CT? Well, it tells us that T is a point on BC, that line, such that BT to TC is 4/3. So my line BTC, if I were to divide it up, that would be 4 parts, and that would be 3 parts, and the whole thing, sorry, terrible writing, B to C is, well, that whole thing is a square, so that'd be 14. So it's 14, I've got 4 parts there, 3 parts there, 7 parts in total. So that means each of these is going to be too long. So B to T will be 8, and T to C will be 6. So TC is 6. Brilliant, that's 6. So now I've got a right angled triangle. Beautiful question, this using all your different parts of geometry. So if I can work out dt, I'm there. Well, it's Pythagoras, isn't it? It's a squared equals b squared plus c squared. A squared is the hypotenuse, or dt. So dt squared is equal to 14 squared plus 6 squared. 14 squared plus 6 squared. Try and do it in my head, but I'm trying to show off I might make mistakes, and I can't do it. But that's 232. So dt squared is 232, so dt will be the square root of that, so the square root of that is 2 root 58. Keeping it exact, just like in the last question. I could get my actual answer for that, which is 15.23, like an exact value, but sorry, an inexact value, and round it. I'm going to keep it as that. So that's 2 root 58. So the final bit of maths I've got to do to work out that angle theta, that's what all this has been about. I know that's 9, so I'm just going to label what I'm doing to help the examiner. SDT, that's 9, this is 2 root 58. I'm going to be doing some trigonometry. It's going to be SO, CA, or TOA. That's my opposite, that's my adjacent, so that means I'm using a tan, that means I'm using this. So tan is equal to the opposite divided by the adjacent, so tan equals opposite over adjacent. So tan theta is 9 over 2 root 58. So theta is going to be the inverse of tan 9 to the 2 root 58. So hopefully when I put that into my calculator, it will spit out my answer for theta, which I can then round to 1 decimal place. So let's do that all in one go. Tan to minus 1, 9 over 2 root 58 is, oops, I forgot to close my brackets. Whoops. What a useful video for you watching me make mistakes. Oh, hold on, no, that really is useful. Close brackets. 30.5779. Right, and I'm going to 1 decimal place, so it's 30.5. Oh, it's going to round up to 30.6. Oh, I hope I got that right. 30.6. Yes, I did. Phew. It'd be a nightmare to get a massive long question like that wrong. Drawing on your diagrams, taking a moment to work out what's going on. You might not work it out straight away, is really important. I figured out to start with what the angle I was looking for was. I then worked out what information I needed to get there. I needed that length and I needed that length, knowing that that was a right angle. That's the way to start these. If you can't see it straight away, start finding some other bits. You got a mark for writing 6. If you could work out that that length was 6, the fact it tells you something about TC being 4/3, that's great. You know that that's something you can work out. Also, you know that it's going to be something to do with the trapezium. Work out some different lengths. If you're stuck, if you've got some time at the end of the paper, figure out some different lengths, even if you don't know exactly what you're looking for. And hopefully, by doing that, somewhere along the line, it's going to help you get to the answer. Right. 3 to go. Right. Okay. Algebraic fractions. Again, people want to make equations on here. We're just doing rearranging. Don't worry, we'll get to solve some equations at the end. But right now, we're still just rearranging. It's just like that previous question where we had to expand the brackets to put it... expand some brackets to be written in a different form. I started with something, just rearranged it until I got there. I'm going to do the same here. I'm going to start by just writing out the question nice and large, and you don't have to do this, but I think it's good for these notes for you guys. Right, now if I were adding some fractions, if I were adding, say, 2/3 plus 3/4, I need to make the denominators the same. The easiest way to do that is to multiply 3 and 4 to make 12. So there's my first thing. I need to make the denominators the same. I'm going to worry about that 1 afterwards, which many of you missed, by the way, or misread as an equals. Do take a moment to look back at the question when you finish it, or even look at it twice to start with. I'm just going to worry about these to start with. So I'm going to choose a common denominator. I'm going to choose to multiply them together, just like I did with that 3 and that 4. So that's going to be my denominator for this one. Then I'm going to have this as a denominator for this one. And then the 1 I'm also going to have to write in that same form. We'll worry about that one in a minute. So I'm writing all 3 of these as a fraction with the same denominator. Now, to get from 3 over x plus 2, I'm going to demonstrate this separately for those of you that don't quite follow this, but I wouldn't write this in my actual exam. If I've got 3x over x plus 2, and I'm trying to get the denominator to be x plus 2, x minus 2, I'm multiplying the denominator by x plus 1. No, sorry, no, that's rubbish. That's rubbish. Just ignore that. I'm multiplying the denominator. It's already x plus 2. I've got to multiply it by x minus 2. So I've got to do the same to the numerator. So my numerator would become that 3x multiplied by x minus 2. So do the same to the denominator as you do to the numerator. So multiplying the top and bottom by x minus 2 gets me 3x, x minus 2. Now this one I've got to multiply by x minus 2, but I've got to multiply everything there, the whole of the 2x plus 1 with brackets on, by x plus 2, because I've already got an x minus 2, I'm multiplying by x plus 2. Final one, this 1, just like it, 1, as long as the numerator is the same as the denominator, I get 1. 4 over 4, 3 over 3, x over x, or even all of that divided by all of that. Okay. Now I'm going to do some expanding. I'm going to, no, first I'm going to combine these. So similar to, back to my algebraic, my normal fractions, that 2/3 is the same as 8/12, 3/4 is the same as 9/12. What I then do is just add the numerators together. The denominator stays the same. So I'm going to write this whole lot, one big fraction, all over x plus 2, x minus 2. And my numerator is going to be 3x, x minus 2, subtract that, subtract that. So I've combined this into one fraction. However, this isn't yet in this form here. I need to have the denominator needs to be x squared minus 4, not that, and the numerator needs to have just an x, some amount of x's and some constant. So to do that, I'm going to multiply this all out. Hopefully I'm not going to make a mistake. Entirely possible I will. And when you do, these are the sorts of questions where you might want to ask for some more paper. But first off, hopefully when I get to the end, there'll be no x squareds on the top. The denominator will be x squared minus 4, and I'll just have some amount of x's plus b's. Right. Let's go. Right, so this top one, 3x times 3x times x is 3x squared. 3x times minus 2 is minus 6x. Subtract. Now, I've got to start some brackets. Really common mistake here. Everything in here is going to be subtracted. So I'm going to start a bracket, multiply this out, and then close a bracket. 2x times x is 2x squared. 2x times 2 is 4x. 2x times x, sorry, I've already done that. 1 times x is x. 1 times 2 is 2. Hopefully no mistakes so far. You might be watching this video going, he's going to realise he's made that mistake in a minute. Anyway, multiplying these together, x times x, brackets again, x squared, x times negative 2 minus 2x. 2 times x plus 2x, 2 times minus 2, minus 4. Right, that's numerator, denominator. X times x is x squared, x times minus 2, 2 times x, sorry, that should be an x there, and 2 times minus 2. Alright. Still looks a bit messy. Let's simplify some of this stuff. Let's simplify those two brackets and this denominator first. I might skip this step if I was doing it myself, but because I'm demonstrating for you guys, I won't. So those x can combine to make 5x. Plus 2. Right, that minus 2x and that x cancel out. Still keeping my brackets in there. They are important. And my denominator is x squared minus 4, because they cancel out, minus 2 and plus 2. Right, oh great, that's a good start, that's promising. Right, now I'm going to have to do some subtracting. What I'm going to do here is sort of multiply out these brackets. I'm going to get rid of these brackets. So that's going to become subtracting 5x, subtracting 2, subtracting 2x. So I'm still not simplifying, I'm just going to write this step out. Again, I might have skipped some of these steps if I wasn't doing a video to demonstrate it to you. So subtract that, subtract 5x, subtract 2, subtract x squared, and then subtract negative 4 is the same as adding 4. Alright, now I've got to simplify these a bit. X squared, I've got 3x squared, take away a 2x squared, take away an x squared. Oh, 3, take 2, take 1. The x squareds are going to disappear. I've got no x squared. That's a really good sign because I know I don't need any x squareds. What about x's? I've got negative 6x, subtract 5x, that's negative 11x. Any other x's? No. Yeah. Just going to cross out the ones that I've done. So I did all the x squareds, I did the x's, right. What have I not done now? Just a negative 2 plus 4, and that'd be a plus 2. And then my denominator being x squared, subtract 4. So there's the correct answer. Lots of you had a very valiant effort at it. The main things that went wrong, hopefully you've picked up what you missed out on, but that negative 1, it does exist, it is there, and it's really complicated. Some people just put a negative 1 at the end. It's a lot more complicated than that, actually. In this instance, it's that divided by that. I've got to turn it into an equivalent fraction. Then the next mistake that people made was when multiplying these out, remembering to put brackets around it, because that 2 is going to become a negative 2 later on. That negative 4 is going to become a positive 4 later on. That's really important. It's very mean of them when they put a negative in front of these adding fractions, because they know people are going to make this mistake. But hey, that's what you're being assessed for. That was question 19. Although I've got some equal signs, I've basically just started with that and gradually manipulated the algebra, we call it, until I've got something in the form that they're looking for. Just want to see if there's anything interesting in the mark scheme. 19. 1 mark for getting one of the terms with a correct denominator. Great, well, there's all 3 there. 1 for getting all 3 of them, showing that the 1 becomes that. I mean, that's multiplied out. The fact it says or equivalent means that this step, just this first stage I've done here, has already earned me 2 of the 4 marks. Then there's some things that allow, if you made some early mistakes, you might get this final mark, even if you made some mistakes with the expanding out. But the final answer being negative 11x plus 2 over x squared minus 4. Right, that's how you do a really hard combining algebraic fractions problem. About as complicated an algebraic fractions question as you can possibly get. It's got 3 different terms, all which need to be multiplied by different amounts. The negative 1 can confuse people, and it's got the subtract as well. This is turning into a long video. Right, they give us a bit of a break here. I don't think this is anywhere near as hard as some of the other questions around it. This rule, the iteration or irritation as David put it, iteration is a rule to find 1 year, n plus 1. You look at the previous year, multiply it by something and add 800. That something might be 2, it might be double last year's profit, add 800. might be, hopefully it's not less than 1, then it means it's getting smaller. The profit is going down. But we've got to find out what this rule is, what this A is, in order to predict what's going on in 2020 and 2021. A number of people didn't read the question properly to realise it was 2 years' time. So let's do two things. Right, so to work this out, it's given us a couple of values, so we can work out what A and 800 are. We can sort of complete this model, find out what that A is. So the profit so I'm going to use that as the second year here, the 2019. So the profit in 2019 is equal to A multiplied by the profit in 2018 plus £800. Now, because I have these two values, I can substitute them in. The profit in 2019 was 29,600. The profit in 2018 was 24,000. So 24,000 multiplied by whatever our A is, plus 800. Now we just need to figure out what A is. I'm going to take 800 from both sides, get me 8,800 is equal to 24,000 A. Then divide both sides by 24,000 to get A, which I think I remember because I've marked it recently is just 1.2. Yeah, 1.2 or 6 over 5. Right, now I've got what A is. Now I've got a rule. The actual rule is take the previous profit, multiply it by 1.2 and add 800. So I'm going to have to do that twice. So the profit in 2020 is the profit in 2019. As ever, I'm writing this out a lot more. A times the profit in 2019 plus 800. I'm writing this out more accurately than I would do if I wasn't making a YouTube video. So what's the profit in 2020 going to be then? 1.2 times 29,600 plus 800, which is 1.2 multiplied by 29,600 plus, divided by, plus 800. 36,320. Just filling in my little table up here for real reason. Now I've got to do that again for the profit in 2021. This time I'm going to multiply the profit. I shouldn't write A, I should just write 1.2 because I know what A is. 1.2 times the profit in 2020 plus 800, which is 1.2 times 36320 plus 800, or 1.2 times 36320, should just use the answer button to avoid errors, £44,384. £44,384. Let's check that's right. Yeah, great. Not going to spend any longer on that one. The most complicated thing is just understanding what this means, that Pn plus 1 is just the year after Pn. And as soon as you sort of follow the rule, to get from one step to the next, you multiply and then add. The most common mistake, I think, with people thinking, well, this is trying to work out, it's not a linear relationship. And what I mean by that is it's not going up by the same amount each turn. It's not even a geometric relationship. It's not being multiplied by the same amount each turn. It's more complicated than that. It's being multiplied by something and added. You can't just find out the multiplier and multiply it each time. It's more complicated than that. But it is a fairly simple rule. Multiply it by a number, add 800. Work out what the number is. That's all you've got to do. Multiply it by 1.2, add 800. Multiply it by 1.2, add 800. You could do that ad infinitum. Penultimate question, and a gorgeous one, or horrible, depending on what you think. The first thing you had to figure out here is that really it doesn't matter about which number they pick. The only thing we're bothered about is whether they're even or odd. We're adding them together. There's only a certain number of things we can do. You can have even even, even. I'm not going to bother writing the plus sign. I'm just going to assume that if I add an even number plus an even number plus an even number, I'm always going to get an even number. 2 evens and an odd will get me an odd number. An even and 2 odds will get me an even number. And 3 odds always gets me an odd number. So that's the main sort of level of thinking. There's no marks for that, but that's what's going on here. Try and simplify it. You could have, and somebody did have a very good go at this, writing out every single possible list of numbers you could multiply together. It was possible here. There were 84 of them. And then work out how many of them were even or odd at the end. Unfortunately, that person made a mistake, a very minor one, and they got no marks for it because of the way the mark scheme works. But let's sort of generalise this a little bit then. Let's think. I'm only bothered about even or odd. So I can make a tree diagram. I'm going to start by either picking even or odd. And then, because I'm picking 3 cards, I can then go even or odd again. And then finally, even or odd, even or odd. Second pick, third pick. So it is a penultimate question on the paper. It's fine to think, it might be asking me to do a really complicated tree diagram like this. If this was a really early question, you're probably making it too difficult. But only 4 marks, so I won't spend forever on it. Right, now let's just have a look at this. Let's see, what am I interested in? I'm interested in this result, even, even, even. No. Even, odd, even. No. Even, odd, odd. Yes, that one would be good. Odd, even, even. No. Odd, even, odd. Yes. Odd, odd, even. Yes. Odd, odd, odd. No. Right, so if I can work out these 4 probabilities and add them together, that's it. That's what I've got to do. So how do I work out these probabilities? Well, first off, gutted for the people who didn't realise there are 9 cards. 5 of them are odd and 4 of them are even. So it means this even, even, even is probably going to be pretty unlikely. In fact, it'll be the most unlikely answer on here. So let's see. So the first one, there's 9 of them and 4 of them even. So that's going to be 4/9 chance of me picking even. Now there's only 8 counters left, or 8 cards left. And actually only 3 of them are going to be even because I've taken 1 out. Then there's only 7 left and 2 of them are going to be even. So 4/9, 3/8, 2/7. What does that give me? Well, when I multiply them together, I'm going to do it in my calculator just because I know it will simplify it down straight away for me without making a mistake, which I am likely to. So 4/9 multiplied by 3/8 multiplied by 2/7. 1 out of 21. So the odds of that one happening are 1 out of 21. 3 more I need to get and I'm there. Right, so how do I get down here? So taking an even, so there's 8 left. How many odds left? Oh, so 5 odds are left. Then I've taken 2 cards, so there's only 7 left, and 4 of them are odd. So I need to multiply those 3 together. I should have written my working for what I'm doing there, really, just to demonstrate to the examiner that I know what I'm doing. Because if a mistake happens, it's really good to explain what you've been doing all the way. So 4/9 times 5/8 times 4/7, 10 out of 63. Okay, let's do them. So now what about down here? So first off I pick an odd, so there's a 5/9 chance of that. Then an even, 4 out of 8, well it's just half isn't it, but too late, already written down. Then an odd, well there's only 4 left, so 4 out of 7. You might notice actually here I've got 5 times 4 times 4 on my numerator. 5 times 4 times 4, it's going to be exactly the same answer. And what about this one? So the probability of getting an odd, also 4/8, probability of getting an even. How many evens are left? I haven't taken any evens out, so still 4 evens left, 4/7. Oh, that's 5 times 4 times 4. Again, that one's also going to be the same. So final bit. The probability that's even is, was it 1 out of 21 plus 10/63 plus 10/63 plus 10/63. Lots of different ways of doing this. However you did it, hopefully you'll have come through and got to the same answer if you did it correctly, which is 11 out of 21, or equivalent. So if you didn't simplify it down, that's also fine. That's probably the easiest way of doing it. Often if things are picked, 3 of them, it's going to be conditional probability. That probability is dependent upon the last one. That's the hardest form of probability question, and my favourites. They're really interesting and they end up being counterintuitive. Second, look to generalise. If you're thinking there's so many different combinations, I'd be listening forever. There's probably a simple way of doing it. Well done to the people who got it right. I'm not going to spend much longer on it though. It's just a really hard question. And this wasn't too bad a one to finish. We've done a lot harder than this in class. Just a little note about, I'm going to just quickly plot what these graphs would look like, but actually no, I can't plot them because I don't know how to plot this yet at GCSE. I know that's a line, I know that's some crazy equation. It's going to make all sorts of different things, but where they meet are the points where the x's and the y's are the same. It's probably only going to be, because there's quadratics in there, there's probably going to be 2 different points, but there might be 0, there might be 1, where I've got a pair of x and y coordinates that are the same. So I'm going to start off by coming up with a formula. I can't solve either of these equations because they've both got 2 variables in them. I need to write this equation with just a single variable. So as I know y is 2x plus 5, I can just substitute that straight in. I can just swap. Instead of having y squared is 6x squared take 25x take 8, I can substitute in 2x subtract 5 for y. I just swap that y for 2x minus 5. So all of that squared is this. Not left myself much room for this, but let's expand that bracket. 2x, just as a quick note by the way, a lot of people made this error. That is the same as 2x subtract 5 multiplied by 2x subtract 5. That's what it means by squaring them. So 2x times 2x is 4x squared minus 10x minus 10x plus 25, or 4x squared plus 25. Lots of people just squared that first one. Squared, sorry, minus 10x take away 10x is minus 20x plus 25. Almost made the mistake that I was just telling you not to make. Lots of people just squared 2x, squared negative 5, and didn't get that negative 20x term. Right, so I'm just going to copy this straight in now. Already expanded it. So 4x squared take 20x plus 25 is 6x squared take 25x take 8. Right, I've got a quadratic equation. We've done millions of these now. I'm exaggerating. I can't solve a quadratic equation unless it equals 0. I've got to put it in the form ax squared plus bx plus c. So 6x squared take away 4x is just 2x squared. Negative 25x plus 20x is minus 5x. Negative 8 subtract 25 is negative 33. Hopefully I'm not making any mistakes. Do you know, I did this the other day just to save me going through and making errors again. Yeah. Okay, just wanted to check that I got that stage right. Right, now I need to solve this. You've got a calculator. It's a calculator paper. One simple way of doing this is use a quadratic formula. A is 2, B is minus 5, C is negative 33, and plug it into minus B plus or minus the square root of B squared minus 4AC over 2A. So that's minus b minus 5 is 5, plus or minus the square root of b squared, so 5 squared is 25, minus 4 times a times c, well, 4 times 2 is 8. 8 times 33. 264. But because it's negative times negative, it becomes positive. All over 2 times a, so 2 times a is 4. I'll just simplify that a little bit so that when I put it in my calculator, it's going to be easy. You could just do all this in the calculator in one go. That plus 25 is 289. 289 divided by 4, right? So pop that in my calculator with the plus and the minus. You find it gives you an exact answer for exact answers for x. It gives you either x is 11 over 2 or x is negative 3. The reason it gives you exact answers is because you can factorise it. Just quickly as a reminder for anybody who fancies it, you can skip on if you want. How I factorise quadratics that have an a value greater than 1 is I multiply together a and c, I get negative 66. I'm looking for things that multiply together to make negative 66 but add together to make negative 5. So they're going to be pretty close to each other. So start with 3 and negative 22. That's not high enough. There's 6 and 11. 6 and 11. Oh, I'm already there. So either negative 6, positive 11, or positive 6, negative 11. Which of them add to negative 5? That one. 6 and negative 11. Right. So I found two numbers. They multiply to make negative 66. They add to make negative 5. The weird bit is that you then, instead of writing negative 5x, I'm going to write plus 6x, take 11x. So these are still equal to each other. I haven't changed anything because if I were to simplify that, I'd get back there. But it allows me to factorise this more easily. Here, these two terms, I'm going to factorise this separately. They've both got 2x in common. 2x times x and 2x times 3. That means hopefully I should be able to get an x plus 3 in this bracket, so I can. Because negative 11 times x is negative 11x, negative 11 times 3 is negative 33. That means I can take x plus 3 as a common factor. I've got to do x plus 3 times 2x and x plus 3 times negative 11. And that gives me either x plus 3 is 0, so x is minus 3, or 2x take 11 is 0, so 2x equals 11, and x equals 11 over 2. You don't need to do both methods. I should probably have specified this. You've got a calculator paper, so I want to show how to solve a quadratic equation with a quadratic formula. But it's also worth knowing that sometimes these factorise, and this sort of question could come up. This exact question could be on a non-calculator paper easily. So I've got two values of x. However you did it, they should be the same. That's not enough. I need a coordinate. I need an x value and a y value. In fact, I may as well write these in here. You could write 5.5 if you wanted. Exactly the same. So I need to work out the y value. Luckily, I've got a formula for what y is. Y is 2x take 5. So y is 2x take 5. If x is negative 3, y is negative 6 take 5. So y will be negative 11. So when x is negative 3, y is negative 11. When x is 11 over 2, y is 2x take 5. Well, 11 over 2 times 2, well, that's just 11. Take 5, y would be 6. So 11 over 2, 6. Brilliant. Negative 3, negative 11, 11 over 2, and 6. Not, I don't think, personally, as hard as the probability question, which is hard to get your head round, or even as complicated as the algebraic fractions question, which I think there are an enormous amount of opportunities to make mistakes. This is probably also one of the harder geometry questions you can get. Right, well done, ladies and gentlemen. Hopefully that will help you. That was 2 hours, crikey. That's how long do you get for this paper? I can't even remember. Probably less than 2 hours. But luckily, you don't have to spend your entire time explaining to people how you're doing it and justifying what you're getting right. Right, all the best. Thank you for watching. Bye.